Now see exercise 1.3, question number 1. Find the modulus and amplitude for each of following complex number. Here we have to find the modulus of this complex number and amplitude of this complex number. Modulus means when we represent this complex number in point form or that in order pair, that distance of a point from the origin is nothing but the modulus. And second is amplitude. So the angle made by the segment joining point with origin with positive x-axis, that is amplitude. So see first example. Given complex number is 7 minus 5y. So we compare this with a plus bi. Therefore a is equal to 7, b equals to minus 5. Now we have to find the modulus. So if this number is z, then its modulus is mod z, or simply we write r is equal to under root a square plus b square. So the modulus of given complex number is, so replace the value of a as 7, so we write here 7 square, plus replace the value of b as minus 5, so minus 5 square, so write here 7 square 49 plus 5 square 25, so we get here 74. So this is modulus of this complex number 7 minus 5y. Next we have to find here amplitude. So if given number is z equals to a plus ib, its amplitude, or we can write here argument of z, amplitude of z, or arg of z, or we have to write amplitude of z is equals to, here we write tan inverse b by a, that is nothing but the value of theta. So we find here theta by substituting the value of b and a. Value of b is minus 5 here, so write minus 5 upon value of a. Value of a is 7. So in this way we get theta is equals to tan inverse minus 5 by 7. This is amplitude and this is modulus of given complex number. Or you can write this as minus tan inverse of 5 by 7, since tan inverse of minus theta is equals to minus tan inverse theta. So using this formula, so this formula we will discuss detail in trigonometric function chapter. If you require the proof, you watch the videos from trigonometric chapter from same channel. Now see second example, root 3 plus root 2i. So compare with a plus bi. We write here a is equal to root 3, b equals to root 2. So modulus of z r for z equals to a plus bi is under root a square plus b square. So substitute the value of a as root 3, substitute the value of b as root 2. So we get here root 3 square as 3, root 2 square as 2. So 3 plus 2 we get 5. So r equals to root 5. Then we have to find the argument of z, that is amplitude of z. So we write tan inverse b by a. So substitute the value of b as root 2 upon root 3. Now third example is minus 8 plus 59. So after comparing this with a plus bi, we get a equals to minus 8, b equals to 15. So modulus of z, that is r equals to under root a square plus b square. So substitute the value of a as minus 8. So minus 8 square plus 15 square. 8 square is 64 15 square is 225. So add these two. 4 plus 5 9, 8, 2 8 9. So we can find the square root of 289, which is 17. So we write here 17 or root 17 square, or directly write 17. So r equals to 17, and we have to find here argument of z, that is amplitude of z, that means tan inverse b by a. So write theta equals to tan inverse, value of b is 15, value of a is minus 8. So you can write this as minus tan inverse 15 by 8. Now see fourth number example, minus 3 into 1 minus I. So first we multiply by minus 3 to this bracket, we get minus 3 minus minus plus 3i. So compare with a plus bi. So we get here a is equals to minus 3, b is equals to plus 3. So if you observe, this point lie in, we know that in first quadrant x is positive, y is positive. In second quadrant x is negative because x dash, y dash. So here x coordinate is negative, y coordinate is positive. In third quadrant this x coordinate is negative and y coordinate is also negative. In fourth quadrant we get here x coordinate is positive, y coordinate is negative. So here a equals to minus 3, b equals to 3. That means when we represent this complex number in order pair, that is in the form of point, so minus 3 plus 3. So minus 3 plus 3, that point lie in second quadrant. So when we have to find exact value of theta, instead of writing tan inverse, we can use this concept. So we will use this concept. Now see, modulus of z, that is r equals to a square, that is minus 3 square, plus b square, that is 3 square. So we write here minus 3 square is plus 9, plus 3 square is plus 9. So we write here 2 times 9, or we write 9 into 2. Square root of 9 is 3, square root of 2 we cannot calculate, so we write r is equals to 3 root 2. Now we have to find argument of z. So write theta equals to tan inverse, value of b is 3, value of a is minus 3. So we get here tan inverse of minus 1. So if you write minus tan inverse of 1, or you can write this as, we know that tan 45 is 1, so we write here minus tan inverse 5 by 4, that is equals to minus tan 45, because tan 45 is 1, tan inverse of minus 1 can be written as minus tan inverse of 1. When we write a negative angle, now we first confirm that point lie in third quadrant. Suppose 1, 2, 3. So this is minus 3, 1, 2, 3. This is plus 3. So this point we represent on graph in this way, minus 3 plus 3. So when we join this P with this origin, this distance is nothing but value of r, that is 3 root 3. The distance of point P from the origin, this O is called pole of coordinate. Then this distance OP we calculate 3 root 2, and we have to find inclination of this OP with positive direction of x-axis. This theta we are going to find. Now this theta we calculate as minus tan pi by 4. So when we write this as here this is a equals to -3, b is equals to 3. So when we measure the angle in anti-clockwise, we write that as positive. When we extend this OP, so when we measure in clockwise, that angle is negative. So this concept we will see in chapter 1 in first paper. So see here, we have to find theta, so we get minus tan 45. So we get, when we measure in clockwise direction, that angle is negative. So we write here this as tan inverse of, or this. So you can write this as minus tan inverse of minus pi by 4. So you can write this answer, or you can write tan inverse of 1, that is minus tan inverse of pi by 4, or tan inverse of minus pi by 4. Both answers are valid. If you find the exact value, this angle, that what will be that angle? We know that this angle is pi by 4. This angle is pi by 4. This angle is 90. So 90 plus pi by 4, you will get the value 135. So 135 will be the answer. Now if you require the answer that provided in the textbook, so you have to write this as tan theta is equals to -1. So tan pi by 4 is 1. So we write this 1 as tan pi by 4. So we write here tan theta is equals to minus tan pi by 4. So use the formula here. Tan pi minus theta is equals to minus tan theta. So in place of theta we have the value pi by 4. So we write here tan pi minus pi by 4 is equals to minus tan pi by 4. So this tan pi minus pi by 4, we write 3 pi by 4 is equals to minus tan pi by 4. Why we convert this? Because for comparing the angle, we require both the sides sign same. Here in left hand side, this tan theta has plus sign and this tan pi by 4 has minus sign. So we reduce this minus sign to plus sign by using this formula. So instead of writing minus tan pi by 4, we write tan 3 pi by 4. So write here tan 3 pi by 4. Now we can compare. Theta equals to 3 pi by 4 because both the tans have same sign. So write here theta is equal to 3 pi by 4. So in this way also you can find the angle. If you not know how to calculate this value, you can write up to this level theta is equal to tan inverse of minus 1, or you can write minus tan inverse of 1, because minus sign you can take out of this tan inverse. Now see next example, fifth, minus 4i. So we compare this with a plus bi. So a equals to minus 4, b equals to also minus 4. So modulus of z, that is value of r, equals to under root a square plus b square. So substitute the value of a as minus 4 its square plus value of b as minus 4 its square. So we get here 16 plus 16, which is 16 into 2. So square root of 16 is 4, square root of 2 we cannot calculate. So we get the value of r is equals to 4 root 2. Now we have to find the value of theta. So theta is equals to tan inverse of b by a. So we write here minus 4 upon minus 4, which is equals to minus minus sign get cancelled. We can write this as tan. When we shift this tan to left hand side, we write tan theta is equals to 1. So we know that tan pi by 4 is equals to 1. But this is not possible. Why? When we consider a point Now point is minus 4 minus 4. So minus 4 is in third quadrant. Here is minus 4. 1, 2, 3, 4. So the point in third quadrant. In third quadrant angle must be. So here angle 0. Here angle is pi by 2. That is 90. Here angle is 180. That is pi. Here angle is 270. That is 3 pi by 2. So angle must be lies between 180 and 270. Here we calculate angle as pi by 4. So we have to consider a point. This point lies in third quadrant. So we have to convert this angle in the form angle between 180 and 270. So for that we have the formula tan pi plus theta is equals to tan theta. So write this formula tan pi plus theta equals to tan theta. Add sugar to coffee. That means in first quadrant all ratios are positive. In second quadrant sin and cosec is positive. In third quadrant tan and cot is positive. In fourth quadrant cos and sec is positive. So we write here tan formula as tan pi plus theta equals to tan theta. So we write here tan pi plus, in place of this theta we have value pi by 4. So write tan pi by 4 is equals to tan pi by 4. Therefore tan 4 pi plus pi, that is 5 pi by 4 is equals to tan pi by 4. So instead of writing tan pi by 4, we write tan 5 pi by 4. So we write here tan theta is equals to tan 5 pi by 4. Therefore theta is equals to 5 pi by 4 is the required answer. See question number 6, root 3 minus I. So we compare with a plus b. So a equals to root 3, b is equals to minus 1. Because coefficient of I is minus here, so we write b equals to minus 1. Now substitute the value of a as root 3. So we write root 3 square, value of b. Value of b is minus 1, so write minus 1 square. Root 3 square is 3, minus 1 square is plus 1, so we get 4. So square root of 4 is 2, so we get r is equals to 2. Now argument of z, that is amplitude of z, equals to tan inverse b by a. So theta is equals to tan inverse, value of b is minus 1, value of a is root 3. Now check the point. So from this we write point as root 3 minus 1. So the sign is plus minus. Where is sign plus and minus? X, y, x dash, y dash. Sign is plus, so x is plus, y is minus. So in fourth quadrant, sign is plus and minus. That angle must be between 270 to 360 degree. So we write this as minus tan inverse of 1 by root 3. So we must know for which angle tan inverse is 1 by root 3. So for pi by 6, so we write this as tan pi by 6 is 1 by root 3. So you can write this as pi by 6, tan inverse of 1 by root 3 as pi by 6. Or you can also use this concept. So first we transfer this tan inverse to left hand side. So write tan theta is equals to minus 1 by root 3. So we write minus. This 1 by root 3 is value of tan pi by 6. Now we require the formula, or we require the angle from fourth quadrant, and in fourth quadrant we know that cos and sec is positive. So we write here formula tan 2 pi minus theta is equals to minus tan theta. So substitute the value of theta as pi by 6. So in place of this minus tan pi by 6, we can write this value, which is tan. So 6 into 2, 11, 6 into 2, 12 minus pi, that is 11 pi by 6. That means instead of writing this minus tan pi by 6, we can write tan theta is equals to, therefore tan theta is equals to tan 11 pi by 6. Therefore theta is equals to 11 pi by 6. So the answer is theta equals to 11 pi by 6. Now see next example. Here only 3 is given. So we write this 3 as 3 plus 0i. That means z equals to 3 plus 0i. So we compare here with a plus bi. We get a equals to 3, b equals to 0. So modulus of z. So we write value of a as 3. So 3 square plus 0 square. So we get 3 square plus 0. 3 square is 9, that is 9 plus 0. So 9 plus 0 is 9. So square root of 9 is 3. So value of r is 3. Now we have to find the angle. First we confirm what will be the angle. Now this point, when we write in coordinate form, so we write 3 0. Here y coordinate is 0. When y coordinate is 0, when that point lie on x-axis, we know that on x-axis y coordinate is 0. So the possibility of angle. Now this coordinate is positive. So x is positive. So on positive x-axis that point lie. So the angle must be 0. So the angle must be 0. So we find the angle, that is argument of z. So theta is equals to tan inverse. Value of b. Value of b is 0. 0 upon 3. That is equals to tan inverse of 0. Because any number upon 0. Any number upon 0. Sorry. 0 upon any number. Any number is equals to 0. So we write 0 upon 3 equals to 0. And we know that tan 0 is 0. So tan inverse 0 is 0. So we get theta is equals to 0. You can write here, or you can add one step more. When we transfer this tan inverse to left hand side, we get tan theta is equal to 0. So you can write tan 0 is equals to 0. So after comparing, you get theta is equal to 0. That value we already confirm here. This point 3 0 lie on positive x-axis. So the angle made by this point with origin, this OP, is 0. Because both OP and x-axis are coincident. So their angle between them is 0. Now say next example. 1 plus I. So after comparing this with a plus bi, so we write here a equals to 1, b equals to 1. So modulus of z, that is value of r is 1 square plus 1 square, which is equals to 1 plus 1, which is equals to root 2. Now we have to find the angle. First we confirm where this point lies. So we write this as 1 1. So 1 1, sign of both coordinate is positive. So the point lie in first quadrant. So in first quadrant, angle must be lies between 0 and 90, or 0 or 90, but 0 is not possible because y coordinate is not 0. 90 is not possible because x coordinate is not 0. So we calculate the value of theta as tan inverse of b by a. So 1 by 1. So 1 by 1 is 1. So write this as tan theta is equals to 1. When we transfer this left hand side, tan inverse to left hand side, we write tan theta equals to 1. And we know that tan 45 is 1. Or you can write tan 45 degree. So theta is equals to 45 degree. That is theta is equals to pi by 4. So in this way we can find r and theta, that is amplitude. See next question. 1 plus I root 3, that we write 1 plus root 3i. So we get here a is equals to 1, b equals to root 3. So calculate value of r, that is 1 square plus root 3 square. So we get 1 square as 1, root 3 square as 3. So square root of 4 is equals to 2. Now we have to find the angle. So first we see in which quadrant this point lie. So we write this in order pair as 1 root of 3. So the point lie in first quadrant. So for first quadrant, angle lies between 0 to 90 degree. So we write here theta is equals to tan inverse. Value of b is root 3. Value of a is 1. So we write here tan inverse of root 3. So we write this as tan theta is equals to root 3, and we know that tan 60 is a root 3. So you write this as tan pi by 3. So theta is equals to pi by 3, or you can write theta is equals to 60 degree. So you can solve next question. So first you have to simplify that, then you have to find its modulus and complex. So try yourself. If you are unable, then watch next video. You will get the answer of question, sub question number 10.